here, you might notice that the way I worded the questions on yours is a little different. I decided to change the way it was written. So the answers are the same, but the questions do look a little different.
For those segments, is it important that you start with the center point or maybe?
No, it doesn't matter. Usually I'll go from the center out to wherever, but no, it doesn't matter. Nick. No, I just meant the ones that were shown on the picture. I mean, it's not wrong if you added more, but those are the only two you have to have. Landon.
Did you just put angle C for C?
No, because if you say angle C, I don't know if you mean this angle or this angle or this angle. So no, you have to use the long name for that angle. Finley. A radius has to go. So again, if you imagine there being a circle that's circumscribed around it, a radius must touch the circle. So it has to go from the center to a vertex. So these would be the radii. The radii are the segments that form the central angles. Okay. This segment is not a radius. This is an apothegm because it's going from the center perpendicular to a side at its midpoint. But again, if you were to draw the circle, that's terrible. If you were to draw the circumscribed circle, the S was not on the circle. I can't do it very well, but any other questions on the top half there? Kylie? It's half of the side. So since the side is 10, it'll be 5. Liam? I'll do that. I should have. I'm not really as picky probably on this particular problem as I would be. I don't know, any different problem. Other questions? Somebody else can hand up. Caroline? It depends on how you do the problem. So if you like I just used the answer up here that was an approximation. What did you multiply down here?
I did the same thing, but I have 13.74.
Okay, so here I asked you to round to the tenths. So I would just go ahead and use that rounded answer down here, but it's not wrong. If I could just see on your paper you wrote 13.74 and you got a different answer, it's not a problem. Yeah, if you do something a little bit different, your answer is a little bit different, doesn't mean it's wrong as long as I can tell why it's different. Okay, any other questions on the top group there? Okay, so 2 and 3 are Heron's formula. Okay, and you use Heron's when you've got all 3 sides in a triangle. So if you know the 3 side lengths, you can figure out the semi-perimeter and then use that to get the area. And again, down here, I'm doing the break each of these numbers into its prime factorization so that I can pull out numbers without having to factor a big number. But if you want to multiply that and then break it down, you can do that. Okay, to me, it's just easier to go ahead and pull out the 4 here. And then I just have square root of 26. Questions on those two? Okay, and then you need to recognize when, and notice also, I'm asking you for simplified radical form. So that means you need to be doing something that doesn't involve trig. Okay, because technically you could do like law of cosines or something and find an angle measure and then do side angle side formula there, but that's not going to give you an exact value. Okay, so for this one, I told you could round. That typically means you can use trigonometry. And that's the side angle side. So when you see these problems, you need to have a trigger in your head like, okay, I have 3 sides, that's Heron's. I have side angle side, that's the side angle side triangle area formula. Any other questions on the first page? Jeff? Law of cosines will find the side length, but we're looking for the area. So if you did law of cosines, you would then have to do area another way, like for example, Heron's or something, right? You didn't get 22.4, right? So law of sines and law of cosines will find an angle or a side depending on what you're given. So the only way that's helpful is if you then use that to get the area. So like I just said, you know, if you have all the sides, think of Heron's. When you have this side angle side situation, don't forget about that formula. Okay, so there's so many different formulas you really need to pay attention to, like making sure you remember when to apply what. Okay, for the two equilateral triangles, when you're given the side length, I would suggest that that's the easiest formula. You don't have to do it that way, right? There's lots of different ways to do equilateral triangles. You can drop the apothem and figure out this little triangle. And then if you were doing the area of that little triangle, what would you multiply your answer by? Sorry. It's not updating here. Let me try. I scrolled, but you're not seeing what I've got. So let me try sharing again. Oops. Okay, for the equilateral triangles, if you find the area of that little right triangle, what would you multiply your answer by? So if you did, hold on one second, let me get this over here. If you did the area of this little triangle, what would you multiply it by to get your total area? Nope. If you found this area, you'd multiply by 3, right? It'd be 6 for this one. So if you were to draw in the radii, Finley, those are the triangles that there would be 3 of, right? So if you wanted to do this whole area and multiply by 3, that would be okay. Or this area times 6. I'm doing 1/2 AP on this one, but you could use s squared root 3 over 4 after you figure out the sides 8 root 3. What you need to be really careful about is making sure that you correctly multiply the 4 root 2 when you're squaring it. Or if you were to do this one by s squared root 3 over 4, when you square 8 root 3, make sure you square the 8 and then also multiply by 3. Okay. Another option is to just do the 1/2 base height. So remember, we talked about this one day that we were online. How do you know that that has to be 8? If you want to drop an apothem here, how would you know that that has to be 8? Liam? Yeah, so one of the things was when you draw in the medians, their point of intersection, the centroid, is a 2-to-1 ratio, right? This is a third of the whole, which means this is 12, so therefore that's 8. What's another reason that this has to be 8? There was another reason. Nick? Okay, yeah, that's true. When you draw in all the radii, that'll be isosceles. Because this is 8, that's also 8. Those are both radii. So again, if you imagine your circle going around the triangle, horribly bad there, the distance from the center to a point on the circle has to be the same. So if you know the apothem and you want to make that, extend that out, that's double. That's only on an equilateral triangle though. Don't be trying to do that on anything else. Nick? They're altitudes of the central angle triangle. Yes. So if this is 4 root 3, that means this whole thing is 8 root 3. Yes, this is the central angle, and when I cut that in half, that's what I'm doing. So this, because those little triangles are congruent, everything, you know, matches up, right? Remember, we just said you could take this and multiply by 6 because that is the same as this triangle. And same thing up here and over here, and you know, et cetera. Yeah, lots of symmetry with those problems. Notice on this one, I didn't even bother finding the side length because 1/2 base height, just think of it as like half of the base. Well, if this is your 1/2 base height, half the base is 4√3. So you can just do 4√3 times 4, and that'll give you the area of the whole entire triangle. So there are lots of ways to do the equilateral triangles and the squares. So you just want to, in hexagons, honestly. So you want to make sure that, you know, you kind of have some different ways of looking at it and use whatever you think is easiest on whatever information you're given in a problem. Okay, this is a regular hexagon. What kind of triangles do you get when you draw a central angle on a regular hexagon? George? George? Yes, that's only for regular hexagons, okay? So one option would be if you want to find the area of that triangle, you can multiply by 6, and that triangle is easy to find if you know the side length. So down here, remember that the radius is the same length as the side because these are equilateral triangles. So if you wanted to do, like, it's a lot easier than what I did here because you really don't have to find all that stuff. But one option is to, so I used the 30, 60, 90 here and found the long leg would be 6√3 and the short leg is 6. So the apothem is 6√3. Okay, the whole side is 12. But we actually already knew that because this equilateral triangle, any of those would be a 12, 12, 12. Okay, so if you wanted to do the area of the equilateral triangle is 12 squared root 3/4, and then just multiply that by 6, you know, that's quick. You don't necessarily have to do it the way I did it. Okay, but I'm doing 1/2 apothem perimeter. Again, you can also do 1/2 of 6 times 6√3 and multiply by 12. So you have lots of options. On hexagons, you can always split them up into equilateral triangles. So if that's helpful, then, you know, doing it that way is on this one would actually be simple. But again, be careful. Hexagons will have a radius and a side length the same. That's not true in general. Okay, squares are simple shapes, but there's lots of different ways to do it. I showed you 2, there's more than 2, but in order to do the area of a square, one option is to find the side length, right? So you can do that 2 ways, at least 2 ways. I drew in the little right triangle here, the little apothem triangle, and since the radius is 6, that gives us divide by √2, that gives us 3√2 for the apothem, and then that means this side length is 6√2. Okay, and then you can just do 6√2 squared. So this would be the same no matter which way you find the side length. Up here, I did the, since this diagonal is, that half diagonal, so radius is 6, this is also 6. And so I use that 45, 45, 90 to find the side length by dividing 12 by √2. Okay, so the whole diagonal is 12, and then divide by √2 would give you these side lengths being 6√2, and then you can square that. Okay, so this work is using side squared no matter which way you find your side. Another option that sometimes it's easy, make a question or comment. Yeah. Yes, but I was actually going to say because the squares are rhombus, you can use the rhombus formula. Do you guys remember the rhombus formula for area? 1/2 diagonal, 1 times diagonal 2, and that's actually easy on this one, right? If that's 6, that makes that 12. 12 times 12 divided by 2, and you're done. 72. 144 divided by 2. Okay, so with squares, treating it like a rhombus is actually easier. Sometimes, it depends on what you're given. You know, it's easy to find the side length, find the side. But again, you can also do the area of that little triangle times 8, or the area of this triangle times 4. You can always break them down into triangles. Any other questions about the square? Other questions about the square? Again, lots of options. I don't want to overwhelm you with options, but it just depends on what you're given as, you know, as to determine what's maybe the easiest way. Okay, now, this is an octagon. A couple of things to pay attention to. What kind of triangle are these little triangles? Isosceles. They are not equilateral if it's not a regular hexagon, right? The other thing is sometimes students think the central angle is 45. and they start doing a special right triangle here, don't forget to divide by 2. 45 would be the central angle measure. That's actually a 22.5 angle up here. Okay, so using trig, we can find the apothem. And then the perimeter, because this is 4, that makes this whole side 8. 8 times 8, 64. Should be 310.4. Questions on that one? Again, you could do the area of this. What would you multiply by if you did the right triangle area? 16. Or you could do this triangle and multiply by 8. Okay. Somebody said they did the 1/2 AB sine C. That was Paul Shetty. I didn't really even think about doing that. But when I'm allowing you to do trig, you can do, if we know this angle measure is 22.5, you know, if you want to find this side length, that rate, because those are isosceles, if you want to find this side length, you could just do 1/2 AB sine C. If you wanted to find those angle triangle areas that way, that will only work if I'm giving you a non-hexagon, something I don't need radicals for. Okay. If I say you can round it, that means you can do trig, including 1/2 AB sine C, or S squared root 3 over 4, or Heron's, but I don't think I would probably combine Heron's with this area. Probably not the easiest way. Okay, so this is a pentagon that's regular. Divide 360 by 5, get 72, cut that in half, and this angle is 36. You know, we don't have the apothem or the side length there. Don't be trying to do like just realize that if you draw an apothem here, it's not going to cut, it's not going to be straight, right? These apothems, I can't really make that a straight line. An apothem here will not be like making a straight segment with that apothem. And a radius, if I draw the radii here, it's not going to make a straight segment with the radius there. So just kind of be careful when you're drawing things in there. All right, so I did trig to find this side length. That's 3.5. That means that the whole side length is 7. And then perimeter is how much? 35. So if you wanted to just do 3.5, oops, sorry. If you just wanted to do 3.5 times 10, you can do that. Just make sure that you're careful so you don't confuse yourself on what you're finding. So common mistake is to forget to multiply that by 2. And so, you know, if you multiply 3.5 by 5, it's going to be wrong. If you multiply 3.5 by 10, that's okay. Just be careful that you're paying attention to what you're finding as you're working through the problem. Okay, and then I did trig again to find the apothem. You could do Pythagorean theorem if you want. Okay, and I'm doing 1/2 AP. So I think somebody told me they used maybe like tangent on this when they just found this a different way and they got like 4.8. Doing the same problem with a different method might give you a slightly different answer. It doesn't mean it's wrong. If I can see what you did and I can, you know, verify it, I can go through and duplicate what you did and I see it's just due to the method. So again, I think he did tangent, what did he tell me? I think he did tangent 54 is equal to A over 3.5. So because he was using this rounded value already, that made this a 4.8 and that made that 84. Like it can be a pretty significant difference depending on how you work out the problem when there's multiple steps like that. So you just want to make sure you're careful about showing your work so that I can, you know, double check it if you have something different than I do. Because that's literally what I do. I take your equation, I look at your setup, and then if you got a different answer, I type it out and make sure that you rounded it correctly and that, you know, what you had was right. And then I do the multiplication of 1/2 AP and check your answer. That's why it takes me like 1,000 years to grade everything, because I'm too careful, I guess. Nick. Yeah, so that's going to throw it off a little bit, right? Just because it's a different method. Tell me what you did again. This angle, so it was a over 6. Uh-huh. Yeah, because you were using the 4.9 there, right? Basically, when I do the problem, I try to use what was given for all my calculations because then it doesn't compound mistakes. If you make a mistake on your apophthegm and then you use that number to find the other side, it's going to throw off that again. And also, you're rounding twice. So it's not wrong. Nick, I would not take off for that as long as I could see what you did. But just know when you're checking your answers against mine, I'm going to try to use the given information when possible, just because then I won't have to round, double round. Any other questions on the pentagon? Okay, so again, you can do the area of this triangle times 10 or the area of that triangle times 5, but that is not an equilateral triangle. So don't be trying to do 6 squared root 3 over 4 for that because it's isosceles, it is not equilateral. Okay, and then for our 15 gone. Okay, I drew the little triangle here, the little apophthegm triangle, to help you kind of think through it and to show me what you're using. So if I don't draw that triangle for you, I would still recommend you do that because that'll help you keep track of what you're finding and what you're given and, you know, as you work through the problem. Common mistakes are forgetting to divide by 2 and multiply by 2 on things with perimeter and whatever. And again, on this one, you can use trig. So if you wanted to find the radius and do 1/2 AB sine of 24, you could do that.